Hello everyone, I'm Matt Kazani from Stroud Water Research Center. Today I will be talking about Part 3, the final portion of the load calculator process. Part 1 started off talking about the different ways you can calculate sediment and chloride loads in the load calculator. It then concluded with how to enter your data-rich rating curves into the load calculator to start the process of sediment and/or chloride load analysis. Part 2 first focused on the variety of ways to download sensor station data. It then focused heavily on data cleanup and preparation for the final process of the load calculator. Today I will go through entering the prepared sensor station data into the load calculator and calculating load results for sediment and chloride. This calculator, like the others, contains quite a bit of text that will provide more detail in the process to help guide you through the load calculator. Please refer to it if you have any questions or need clarification on any of the steps. Once your data spike has been edited for valid values, it is ready to be placed into the load calculator for final processing and analysis. What you want to start with is to copy over the date and time from your edited worksheet within the storm spike workbook by copying just the values, so drag. So you hit the end, right click, copy. Next you want to take it over to the load calculator and go to the data import sheet. The load table will still remain blank and you cannot add in data here, and you don't want to. If you do, you will mess up the inner workings of the calculator. So be sure you're on the RNG part of the data import sheet. Then you want to left click underneath date, right, and then choose the values paste option. You should paste all your values in. Now you can repeat the copy and paste steps for depth, conductivity, and both turbidity values. Okay. When you're finished that, you can ignore the other columns within the data import sheet. These are actually set up for an old style of importing data from the Dreamhoster site and whatnot when it was formatted this way, where the only way you could copy it over was through the whole sheet rather than piecemeal like how we did. So these can remain empty for right now. Next, we can then go to the load table. It will now have actually totals for your load, but there's one thing that we might have to tweak depending on the length of our data set that we input. With how the calculator is set up, it does not go indefinitely down with calculations, and there might be a little bit of an issue at the bottom of the load columns. So what we want to do is to try gingerly scroll down. You can actually, to make it go quick without overshooting, you can click your mouse wheel and drag down. So literally the center wheel, click it, you get this little icon, and then you pull down to scroll a little quicker. Oop. So for this example, we don't have the issue of a weird value. At certain lower, smaller storms and all that, you actually will have a weird little error at the bottom of both of these loads, where you'll have an E, which is an exponent, and it's a very large negative. This actually affects your load. So all you would have to do if you're in that scenario, you would need to go to Review, Unprotect Sheet, that way you can enter and click, and you would scroll down to that lower exponent negative, and then just make it into a 0, and then reprotect the sheet, and that would change your load to the correct estimate of how much sediment and chloride went through during that storm. This concludes my talk on how to use the load calculator to analyze storm data and data spikes recorded from your sensor station. As a reminder, before using the load calculator, all rating curves need to have a high level of completion. Also, be sure that the rating curves remain up to date with relatively recent field sampling and measurements, since streams are dynamic systems that can change over time. To make your life easier as well, be sure to do any of the data preparation before getting to use the load calculator. This means making time during your quarterly data QC to clean up your data, just like how I showed you in the video. Thank you for watching. I'm Matt Gazzandi from Stroud Water Research Center.